All right, so example 3, guys. We're going to solve x cubed minus 4x squared plus x plus 6 is less than or equal to 0. So I need to find my p's and my q's because I've got to find those x-intercepts or those zeros, right?
You're kidding me, right?
No. All right, so p is going to be the factors of what number?
6.
Which are?
1, 2, 3, 6.
With plus or minus, right?
Yes.
Okay.
Maybe, I don't know.
And q is going to be the factors of what number?
1.
Which are?
1.
Plus or minus 1?
Minus.
Okay, so then we're going to take every p over every q, but we're lucky on this one. We only have one q. That's a 1. So all of your p's are divided by 1. So you just get plus or minus for all of them. 1, 2, 3, and 6.
Are we done?
Is that it?
We're done with that box.
Really?
So that's our first step, is we got to find, well, we're going to have to find our zeros, or our x-intercepts, okay? Because this is not, now are we going to find any vertical asymptotes on this one?
No.
Why not?
I don't know.
Not a fraction.
It's not a fraction,
I guess.
okay? It's not a rational function, so no vertical asymptotes. So we've got to find those x-intercepts, which are the zeros, and this is the way we find the zeros if we can't factor it. And that one was not, this is not a factorable problem. So then we have to pick one that we want to use, and we're going to divide. So pick a number there.
2.
Okay. So let's try 2.
Or you can give us a hint.
Or we can just try 2.
I think 2.
2 sounds splendid.
Right, it's gonna be wrong.
No, 2 sounds swell.
Splendid is better.
Good lord, whatever. No.
And it worked.
Did it?
Yes.
How?
So if I go down to, I'm going to write my zeros at the bottom of this box here.
Oh.
So I have a 0 at x equals 2. How many zeros am I going to have total?
3.
3. How do you know?
Because the degree of the highest.
Very good. So the degree of this polynomial there is 3. So how am I going to find the other 2?
So you just plug that back
Yeah,
in,
you
right?
could no. You can
Or you
just.
do something
You can
stupid.
just factor.
Oh, factor.
Yeah, that's going to be the easiest because I could pick another one and plug in.
I didn't mean
And as long as they are integers, it'll work. But if it's a fraction or something like that, it may not. So we're left with, what's that, x squared minus 2x minus 3. So we're going to set it equal to 0 and solve. So factor it. So what multiplies the 3? This subtracts the 2.
Negative 3 and 1.
Okay, so negative 3 and positive 1.
Yeah, it's just normalized.
Set them each equal to 0 and solve.
Yup.
So we get negative 1 and we get 5.
3.
Oh, 3.
Yeah.
Making sure you're paying attention to me.
No.
I'd rather be asleep, but you know.
Jordan, how are you gonna pass this class if you sleep?
Day.
George?
Okay, let's factor. So let's rewrite. Remember we had x squared, I'm sorry, it's x cubed. Was it minus 4x squared plus x plus 6 was less than or equal to 0? And now we can write that polynomial there as a product of factors, of the linear factors. So I'm going to take that 2 and plug it back in as a factor, so it's going to be x minus 2. And when I take the 3 and plug it in, it's going to be x. And the negative 1? X plus 1 is less than or equal to 0. Now we're going to do the same thing we did. We're going to make our sign chart. What goes on my number line? X-intercepts. We don't have any vertical asymptotes, do we? So where were my x-intercepts again?
2, 3, and negative 1.
All right, so I'm going to put my infinities there. And put your x-intercepts, your zeros there in order. I'm going to space them out here so I have room to kind of work in between them.
Good job.
And I'm going to plug it in. Now, guys, I have a choice. When I plug these in, I can plug them into the original problem right here, or I can plug them into my factored form, okay? A lot of times the factored form is easier. So, but first let's pick some numbers. So I need a number between negative infinity and negative 1.
-2.
Good. Between negative 1 and 2.
Positive.
0.
Wait, oh, okay.
Between 2 and 3.
2.5.
And between 3 and infinity.
4.
Alright. So,
1,000.
let's plug in the negative 2. Personally, guys, I'm going to use the factored form. So, watch this. Watch up here when I do this first one, and then I'll pause the video and I'll let y'all copy it, and then we'll move on together, okay? So, just, let's plug in the negative 2, and I'm going to plug it into my factored form. So, it's going to be negative 2 minus 2 times negative 2 minus 3 times negative 2 plus 1. I really don't care what the number is going to be. I just need to know, is it positive or negative? So let's work that out right there. Well, actually, just wait on me there. Okay, so look up here, guys. So I told you go ahead and start working it, and then I realized what I'd said. Look at what we have. The first one is negative 2 minus 2. What kind of answer is that going to give me, positive or negative?
Negative.
Negative.
Yeah.
What about negative 2 minus 3?
-2 minus negative.
And negative 2 plus 1.
Negative.
And so what's a negative times a negative times a negative?
Negative.
So my answer here is going to be a negative. Doesn't matter what the actual number is. I just need to know, is it a positive or a negative answer?
I have no idea what you just did.
All right, well, let's do it again then with the 0. So let's plug the 0 into the factored form. And I don't care what the numbers are. I just want to know, is it going to give me a positive or a negative answer? So that first parenthesis was 0 minus 2, positive or negative?
Negative.
Whoops. I don't know why I put a number there. I was trying to put a parenthesis. All right, what about 0 minus 3, positive or negative?
Negative.
What about 0 plus 1, positive or negative?
Positive. So this is going to be positive.
And what's a negative times a negative times a positive?
Negative.
It's positive. Two negatives make a positive times a positive is positive. So, I know in that interval all the numbers are going to be positive. Alright, so I'm going to, I'm going to go ahead and do this with the video playing. So, let's plug in the 2.5. And this is the reason I did it, because when we plug in fractions or decimals, they get a little messy sometimes. Remember, we don't care what the actual digit is, we just care if it's positive or negative. So, let's plug in the 2.5.
I care about the
What's 2.5 minus 2? Positive or negative?
positive.
It's positive. 2.5 minus 3.
Negative.
2.5 plus 1.
Positive.
And what is a positive times a negative times a positive?
Negative.
It's going to be a negative. So I know that all the numbers in that interval are going to be negative. And then we're going to plug in the 4.
It's going to be positive.
Yeah, it's positive.
We still have to make sure though. So plugged in the 4. What's 4 minus 2? Positive or negative? 4 minus 3? And 4 plus 1. Which positive times a positive times a positive is
Positive.
positive.
I'm positive. That's positive.
Alright. So, but what was our problem? We wanted to know where the polynomial was less than or equal to 0, didn't we?
Yes.
What kind of numbers are less than 0?
Negative numbers.
So we're looking for where our negatives are.
And our 0.
And because it's equal to, that means we're going to use brackets on the numbers. Okay? So where did we have negatives at? Where is my first one in my number line?
Between negative infinity to negative 1.
Okay, and negative 1's going to have a bracket. And what about my next one?
2 to 3.
And they're both going to get a bracket. And so that is my actual solution to this problem.